Hi, this is Dr. Sharmili, Assistant Professor, Division of Agronomy, Department of Agriculture, Karani Institute of Technology and Sciences, Coimbatore. And the title which I'm going to discuss is on Integrated Nutrient Management. Before entering into a title, I'll just give a brief intro why we are having this integrated nutrient management as one of the important lecture in our course. Students, we are currently facing a global challenge called soil fatigue. For decades, we have treated the soil like factory, pouring in high doses of chemical fertilizers to get quick yield. But today, the response from the soil which we are getting back is dropping. In many regions, we now have to apply double the fertilizers just to get the same yield which we got few years back. This nutrient use inefficiency is a massive economic drain on farmers. So, relying solely on synthetic fertilizers of nitrogen, phosphorus, and potassium is just like feeding a human only sugar for all the 3 times a day. It will provide us energy, but for a long term, we won't get any nutrition. This leads to multi-nutrition deficiency like zinc, boron, sulfur, etc. So over-dependence on chemicals alone will destroy our soil structure, it will kill beneficial microbes and leads to environmental issues like groundwater pollution and soil acidification. So this is where this concept of integrated nutrient management comes in. This integrated nutrient management is not about whether organic versus chemical or inorganic and all. It is about balance and synergy. It is the deliberate, calculated combination of 3 different sources of nutrition, that is, chemical fertilizers, organic manures, and biofertilizers. So, the philosophy of INM is simple: just feed the soil, not just the crop. Our goal today is to learn how to synchronize these nutrients to ensure to achieve maximum productivity without compromising the soil health for future generations. So, integrated nutrient management means judicious and combined use of chemical fertilizers, organic manures, and biofertilizers to supply nutrient to the crops. We know that crops remove nutrition from the soil every season, so we must replenish them so that if we use only chemical fertilizers, soil health will decline. And if we use only organic manure, nutrients will not be sufficient. Therefore, this concept of integrated nutrient management is to use all the sources together to maintain the soil productivity and to protect the environment for a longer term. So while developing this INM for a crop, we must consider the previous crop which has been grown in the same field, legume effect, residual fertilizer effect, and the contribution of organic nutrients. And when we see the components of integrated nutrient management, the nutrient supply for integrated nutrient management can be obtained from various sources like farmyard manure, compost, green manures, and crop residues, which will improve the soil fertility status. And going for crop rotation, intercropping of legumes along with cereals will also improve the soil nutrient status. And including biofertilizers, application of biofertilizers like rhizobium, azotobacter, azospirillum, phosphorus solubilizers, mycorrhizas, cyanobacteria, PGPR. It will increase the availability of nutrients to the crop plants, and all these together will serve as an important supplementary source of nutrient along with chemical fertilizers to our crop plants. And when we see the advantages of integrated nutrient management, this integrated nutrient management reduces harmful effect of excessive fertilizer use in our field. It also helps to reduce the nitrogen loss from the soil. It maintains physical, chemical, and biological properties of the soil. It provides balanced nutrition to crops and prevent nutrient deficiencies in our crop. It also reduces pollution of soil, water, and air around us. Therefore, integrated nutrient management is very important for sustainable agriculture. Now comes the concept of fertilizer use efficiency, otherwise known as nutrient use efficiency. Fertilizer use efficiency means it is the ability of the crop to use the applied fertilizers effectively. The fertilizer which we are applying, for example, if we are applying 150 50 50 of NPK, the ability of the crop to use the fertilizer which we have applied, we call it as fertilizers efficiency, because not all the applied nutrients are used by the crop. Normally when we see, nitrogen use efficiency of most of the crops is about 30 to 40%, phosphorus is about around 20%, and potassium is about 50%. All the remaining nutrients will be lost by various means like leaching, fixation, or volatilization. So proper management is needed to increase the nutrient use efficiency in our cropland. When we see the factors affecting this fertilizer use, nutrient use efficiency, some of the important factors, the first one is choice of variety. Normally we have to select high yielding varieties, because these high yielding varieties are highly responsible to the fertilizers which we are applying when compared to traditional varieties. And also the date of sowing, time of sowing is very important, because delayed sowing not only reduces the growth and yield of the crop, it also results in poor response to the applied fertilizers. And maintaining optimum plant population also plays a major role, because only if we maintain optimum plant population in the field, the fertilizers which we are applying in the field will be effectively utilized. And water management will also is also very important, since water is very important source for nutrient absorption. And weed management is very important, because weeds are major competitors with the crops. It will absorb more nutrient when compared to crops, and it will ultimately reduce the crop yield. So weed management is also very much important. Next is fertilizer management, that is when to apply, how to apply, how much to apply. The knowledge on all this is very much important for a good nutrient use efficiency improvement. So instead of dumping all the fertilizers as basal dose, it is recommended to go for split application of fertilizers, and also placement of fertilizers to improve the nutrient use efficiency. And not only we have to apply or concentrate only on macronutrients like NPK, secondary nutrient and micronutrients should also be considered, because only if the deficiency of these are corrected, it will help in better absorption of macronutrients. And for Indian grain based system, the normal NPK ratio which is recommended is 4 is to 2 is to 1. So for this, only if we go for balanced use of fertilizer, the fertilizer use efficiency will be further improved. When we see the factors affecting the crop response to manures and fertilizers, the crop response to fertilizers depends on various factors like soil factors, crop factors, agronomic factors, and other factors like climatic factors. Only if these conditions are favorable, fertilizer response will be high. And if these conditions are poor, fertilizer response will also be low, even if we apply more fertilizers. So let us now see all these factors one by one. The soil factors play a very important role in declining how well a crop responds to fertilizers. Some of the important soil properties are soil texture, soil moisture, soil fertility, and soil reaction. If the soil has poor physical condition, plant growth will be poor, even if you apply more fertilizers there. So in coarse textured soil, for example, in coarse textured soil like sandy soil, nutrients are easily lost by leaching. So fertilizer should be applied in small doses but infrequent doses. Whereas in fine texture soil like clay soil, nutrients are held very strongly. So response to fertilizers will be better when compared to sandy soil. So if the soil fertility is already high, crop response to fertilizer will be less, because nutrients are already available in the soil. So higher organic matter in soil will improve the nutrient availability, and it will increases the fertilizer response. And in acid soils, rock phosphate is more useful, because phosphorus fixation will be very less in acid soils. Crop characteristics also affect how fertilizers are utilized in cropland. High yielding varieties and hybrids respond more to fertilizers compared to local varieties because they have high nutrient demand when compared to local traditional varieties. The ability of roots to absorb nutrient depends on cation exchange capacity of the roots. We all know this. And dicot plants usually have higher cation exchange capacity than monocots, so that they can absorb more divalent nutrients like calcium and magnesium. So plants with well-developed and spreading root system will absorb more nutrition from the soil, and association of fungus, mycorrhizal fungi with the roots will help in better absorption of phosphorus, potassium, zinc, and copper to the crop. However, very high fertilizer application may reduce mycorrhizal activity in the soil. When we see agronomic factors and other factors like climatic factors, this agronomic practices which we follow in our cropland also influences the fertilizer response. Timely sowing will ensure proper crop growth and better nutrient utilization. Proper spacing will help the plant to get enough nutrition for them, enough light for them, and enough water for them. Correct dose, correct time, correct method of fertilizer application is very much important. And when we see the climatic factors, climatic conditions prevalent in the cropped land is also will also affect the response of fertilizers of the crops. Under drought or excess moisture condition, root absorption becomes poor. So foliar spray of nutrients can be recommended in under such condition. And in high rainfall areas, nutrients may be lost by leaching. So split application and slow release of fertilizer, slow release type of fertilizer should be used for better. What is this slow release fertilizers? So slow release fertilizers are fertilizers that release nutrients slowly for a longer period of time. So these fertilizers have developed to prevent the nutrient losses due to leaching, volatilization, and nitrification. They provide steady supply of nutrition to the crop throughout the growth period of a crop. So this increases the fertilizer's efficiency and will also reduce the wastage of fertilizers. So slow release fertilizers are mainly available for nitrogen because nitrogen is easily lost from the soil. So some of the example for slow release fertilizers are neem coated urea, sulfur coated urea, lac coated urea, tar coated urea, IBDU and all. So these materials will act as nitrification inhibitors which will slow down the conversion of nitrogen. So students, in conclusion, integrated nutrient management helps in balanced nutrient supply, improve soil health, it will increase the fertilizer use efficiency and it ensure sustainable crop production. Therefore, it is essential practice in modern agriculture. Thank you.